High-stakes DevSecOps cannot survive on standard AI. Pristine-looking code collapses the moment it encounters the invisible pressures of a production environment. We are facing a frontier epistemic rupture. There is a massive, growing gap between the conversational fluency of large language models and their total lack of underlying structural logic. Most teams rely on vibe coding. They use natural language to coax a model toward a rough approximation of what they need, essentially guessing their way into an enterprise architecture. This reliance on probability leads to total system failure. It results in broken CI/CD pipelines, distributed deadlocks in database optimization, and compromised threat hunting. Natural language is a lossy, entropic control medium. It is incapable of serving as a control mechanism for zero-trust execution. This visualization shows semantic saponification, a thermodynamic decay process. When complex instructions travel massive token horizons, their sharp edges wash away. A specialized engineering persona dissolves into homogenized, generic boilerplate. Over time, the structural integrity of the instructions simply evaporates. To survive this, agents must be governed by the Sovereign Cognitive Operating System, or SCOS version 6.0 strict. It is a 28-layer cybernetic stack. Transitioning from semantic suggestions to rigid cognitive physics replaces fragile assistance with deterministic execution. The foundational layers, metaphysical substrate and semiotic compulsion, act as a containment vessel. Fluid reasoning is forced into an absolute structural mold. Standard prompt engineering is abandoned. In its place is Prompt Declaration Language, or PDL version 1.0. PDL uses topological decorators. These are cognitive bytecode. They physically deform the model's attention manifolds to enforce constraints before the first token is even generated. This creates an anionic architecture. The autonomic isolate decorator acts as a mathematical barrier. It treats specific tokens, like a shared database request, as vectors that must be rejected. Masking these logits renders dangerous anti-patterns mathematically impossible. Standard AI safety rules are suggestions a model can bypass. This masking makes the unauthorized choice a physical impossibility within the latent space. By altering the physics of thought at the logit level, SCOS eliminates unauthorized choices during the drafting phase. Band 3, Sovereign Identity, addresses the problem of temporal execution, keeping an agent's specialized purpose stable over thousands of turns. Text-based personas are discarded. Instead, the agent is defined by an epistemic matrix. These 5 coordinates converge to form a unique cryptographically signed hash. It maps goal orientation, anti-goals, communication style, tooling limits, and history. This ECDSA signature establishes cryptographic sovereignty. The agent's identity is an immutable mathematical state, not a conversational style. To prevent attention entropy collapse, SCOS uses synecdotic anchoring. The context lock decorator re-injects these exact identity coordinates into the model's attention sink every 2048 tokens. This persistence ensures the specialized engineering persona survives context saturation indefinitely. Every model pays a projection tax, a 10 to 30% loss in reasoning fidelity, that occurs when it tries to handle complex logic and strict syntax at the same time. The tax hits hardest when generating zero-entropy syntax, like a C4 model or a JSON schema, during primary inference. Draft-conditioned constrained decoding, or DCCD, solves this. It is a 2-step inference procedure. In Phase 1, the model generates a high-entropy semantic draft. It focuses purely on reasoning, unconstrained by formatting rules. In Phase 2, that reasoning is projected onto a zero-entropy output schema. Formatting is enforced only after the logic is finalized. The immune-aware Petzold loop governs this, separating abstract reasoning from deterministic code generation. By decoupling intent from syntax, SCOS has demonstrated a 24% increase in logic fidelity, eliminating the interpretive fracture that ruins standard AI code. Band 4, Orchestration, manages the dynamics of multi-agent systems and the inevitable logic failures they encounter. The symbolic immune system archives historical failures as algorithmic trauma. SCOS does not just read error logs, it maps the exact geometry of the failure as a persistent Betty 1 loop. These failures are encoded as hypervectors in a vector symbolic architecture. This creates a permanent, non-destructive record of what went wrong. This creates night null memory. Like these repelling magnets, the system identifies anti-patterns and creates a repulsive force to avoid them. Failure-informed prompt inversion uses these archived hypervectors to deflect attention weights away from repeats of past mistakes. This immune response is how SCOS agents achieve zero-shot syntax success in high-complexity environments, like EVM smart contract engineering. The terminal state of the framework is band V, autopoiesis and governance. Using structural causal modeling, this band ensures the agent relies on causal intervention rather than hallucinated correlation. This graph shows the Confidence Fidelity Divergence Index, or CFDI. When a user demands a design that violates mathematical or physical laws, like a CAP theorem violation, the model's internal confidence may remain high while its actual fidelity to the constraints plummets. This trigger forces an epistemic escrow. The system quarantines the contradiction instead of generating a hallucinated compromise. SCOS agents possess the structural autonomy to refuse mathematically impossible directives. The 28-layer SCOS framework represents the end of the conversational AI era for enterprise architecture, translating high-level intent into rigid generation constraints. This alters the mathematical physics of the model's thought process. Standard prompt engineering is brittle and entropic. Sovereign agents are verifiable and cryptographic. Because SCOS enforces deterministic execution and architectural immunity, it is already yielding zero-defect performance in smart contract engineering and CI/CD pipelines. To build systems that survive in hostile, adversarial environments, we must stop talking to our AI and begin architecting its reality.